Hello everybody. In this session of e-Pachashala, we will be seeing two concepts of agrotech and geotech. First we shall see about agrotech. Agriculture and textiles are the most important industries in India. They are interlinked with each other. Like every other industry, even agriculture, farming, marine and forestry use textiles either in the form of fiber, yarn or fabric. Decrease in the availability of resources such as land, water, energy and increase in population pressure along with high standard of living and pollution has resulted in use of agrotextiles. It can control climate, ecological degradation and result in effective use of water, reduce use of pest control chemicals, save energy and can even improve production quality. Some of the technical textile products covered under agrotech are shade nets, mulch mats, crop covers, anti-hail nets, bird protection nets and fishing nets. The consumption under agrotextiles in India is estimated around rupees 487 crores. Agrotech segment is estimated to provide employment to 65,000 people. The demand for agrotech products like shade nets, mulch mats depend upon the performance of agriculture sector and also on the awareness and acceptance of products by farming community. The Indian government has taken several steps to increase the production and consumption of agrotextiles. One such step is introduction of subsidies towards usage of agrotech. The National Horticulture Mission has been actively promoting these products throughout the country. Definition: all the textile products intended for the use in the agriculture production comprising of farming, horticulture and animal husbandry and forestry can be considered as agrotextiles. Any type of fiber, yarn or fabric used for the production or enhancement of the shelf life of any agro product is called as agrotech or agrotextiles. The main objectives of this segment is to gain knowledge about various textile materials used in the production of agriculture products and understanding the importance of agricultural textiles. Now we shall see the different types of agricultural textiles. The main textiles what we are going to see first is shade nets or shade fabrics. The shade nets are woven or knitted fabrics used for the production of plants from wind, extreme climatic conditions to reduce water evaporation. India is the second largest producer of flowers, fruits and vegetables. Therefore, use of shade nets is very significant. Shade nets have widespread applications in the cultivation of vanilla, tea plantation, processing and drying of agricultural products, growing and preserving flowers, fruits and vegetables. Rose, orchards, grapes, cabbages, pepper are some of the major fruits and vegetable crops which use shade nets. Shade nets are also used in cattle feed, grain storage areas, parking lots and water pool areas as cover for dusts. It is also used to maintain humidity in greenhouses and plant nurseries, which in turn increases the time for the presence of water content in the soil. Shade nets are usually made out of woven and knitted polymers, polypropylene and sometimes with cotton, jute, coir and polyester as blends. Medium texture and thickness, high tear elongation, resistance and lightweight are the common physical properties of shade nets. The standard size of nets vary from 2, 3, 4 and 8 meters in width with 25, 50 and 100 meters in length. The most common dimension of these nets are 3 meters width by 50 meters length with a GSM of 120 to 180. Green and black are the common colors used for the manufacturing of shade nets. The depth in the color varies from 20 to 90%, which indicates the degree of shade provided by the shade nets. The shade depth percentage also depends upon the application and type of plants under cultivation. Now we shall see the next type of agro-textiles. Mulch mats are ground covers. The textile material used to cover the soil around the plant to prevent the escape of soil moisture and nutrition loss and feed control is called as ground cover commercially and mulch mat technically. This helps in reduction of chemicals used as fertilizers and also aids in the maintenance of soil temperature. A mulch mat can reduce runoff, increase penetration of rainwater, controls erosion and corrects the chemical balance of soil. It acts as a barrier between pests and the seeds or plants. This sheet of fabric can also prevent the attack of diseases. Apart from these major results, mulching produces secondary effects such as improvement of soil structure, increase in microactivity, earthworm population and root system. The growth of weeds is better prevented by black film in contrast to clear film. It also absorbs more heat and energy from the sun, which is retained for a longer period. Generally, mulch mats are used for vegetables and fruit crops with short life period. The planting areas are covered with mulch film wherein holes are made where the seeds are put in. The major advantage of mulch sheets is that it decreases fruit rotting and falling of fruits to the ground. Wool, jute and coir are the common natural fibers, and different types of polymers and their blends with other natural fibers are used for the production of mulch mats. Weaving and non-woven techniques are used to make mulch mats. Mulch mats can be made as thin films also. Wool fiber is used for designing non-woven mulch mats, whereas jute and cotton fibers are used for woven mulch mats. Polymer is used for making mulch films, which are vary in thickness and microns. Depending upon the fibers used, the mulch sheet can be biodegradable or non-biodegradable. Now we shall see the next type, anti-hail nets. Anti-hail nets are used to protect crops like apple and lychees from hails in high latitude and hilly areas like Himachal Pradesh, Jammu and Kashmir, UP and northern states like Assam and Manipur. The anti-hail nets are commonly provided for each individual tree. They are woven from high molecular and high performance polyethylene yarns or a combination of monofilament. Even knitted tapes with finish against UV rays are available in the market. These nets are flexible, light, strong and easy to spread and can be placed on simple support structures. These nets are transparent in color with small hole-like structures. Their GSM varies from 60 to 100 size. The next type of agro-textiles is bird protection nets. Most of the fruit farmers face the major problems of fruit being bitten by birds, which results in heavy loss of crop and income, for which bird protection nets are right solution. This is a net-like fabric which is used to cover the fruit such that the birds are unable to pick it. This is designed in such a manner with small holes which allows the movement of bees and air to maintain the shade, prevents rotting or fungi formation. It also allows penetration of light required for the growth of the fruit. Bird protection nets are manufactured with a GSM of 25 to 40. They are lightweight knitted fabrics with tough, durable, tear strength properties. The size of the nets are available from 1, 2, 3 and 6 meters with a width of 10, 20, 50 and 100 meters in length. The fibers used are high-performance polyethylene yarns and monofilament yarns. Generally, these fabrics are given UV protection finish. The common colors used are green, blue and white. The next type of agro-textiles is crop covers. The major role of crop covers is to create a suitable microenvironment for seed germination and growth of small plants. A crop cover is a large sheet of mesh-like fabric with small holes placed over the entire area of crop to protect them from extreme heat or cold temperatures. Some of these are also placed over newly planted saplings which are transferred to the field. This helps to maintain the humidity needed for the crops to grow. On an overview, it is said that crops show a rapid growth resulting in early harvest when covered with crop covers, unlike plants which are exposed to natural conditions directly. These covers also protect the plant from insects, heavy rainfall, hail, snow and wind. One of the major advantages of crop covers is prevention against cross-pollination, which in turn results in improved crop quality. Crop covers are available in oven, non-oven and sheet or film structures. The fibers commonly used are polypropylene. They are lightweight, white material with a GSM of 17 to 19 for hot climate and 20 to 30 for the cold climate. Great care has been taken to keep their weight of the fabric low, which prevents the crops from being crushed. These fabrics are available in the forms of rolls of 3 meters to 450 to 500 meters length. The next aspect we will be seeing in agro textiles is fishing nets. One of the most important textile materials used in the fishing industry is fish nets. Fishing nets are mesh-like knitted or knotted fabrics used for marine and inlay fishing by fishermen and fishing boats. Generally, fishing nets are constructed by single, double or U-knots. The main purpose of these nets are to allow the fish to enter into them when thrown into the water bodies and hold them when drawn out of water bodies. The size of the mesh or the holes vary from 10 mm to 2000 mm based upon the type of fish to catch. The main property of fishing nets are high tensile and knot breaking strength, high abrasion resistant and low drag resistance. The fishing nets used in ocean and seas are transparent and invisible in water. The fibers used are high performance polypropylene and nylon. The fibers are made into thick ply yarns or monofilaments and multifilament tape yarns. These nets are available in 100 meters, 250, 500, 600 and 1000 meters pool. Now we shall conclude saying that agro textiles is a fast growing area where number of researches to improve the quality of crops and fruits are carried out. It also yields a huge amount of income through exports. In India, the making and use of agro textiles is limited, unlike Europe and American countries. The awareness of technical production and use of agro textiles has just stepped into India. Hence, there is huge potential for research and manufacturing of agro textiles. Now we shall see the next segment of this unit, geotextiles. The term geotextiles is new to the field of textiles. It is known to the industry only for the past 20 years. But as per review, it is clear that the term is new, unlike its usage which dates back to 17th century, wherein jute fabrics were used to hold sand for prevention of flood water. The development of geotextiles has also been an industry-led science. Geotextiles are manufactured fabrics that are used to withstand and or support the environment of the earth and its movement, earths like floods, earthquakes, such that the damage caused to life and assets is minimum or 0%. Geotextiles are particularly referred to porous synthetic, woven or non-woven material. These fabrics are specifically engineered materials to suit a particular application. The first type of geotextiles was made in Dutch, which was a woven heavy steel wire with polypropylene textiles to manage coastal land reclamation. Later on, these fabrics were made into specific composite material to suit civil engineering purposes. The establishment of International Geo Textile Association in 1978 led to the coordination for development of geotextile design and utilization. The major objectives of this segment is to know the role of geotextiles in construction and engineering structures. Apart from that, to know about textile products and its application. Geotextiles has been having 3 different generations for development. The first generation geotextiles are fabrics which are manufactured for carpet and sacking materials, which have no technical production process involved. The fibers were just spun, woven in simple manner and used in limited application. Jute and coir are the common first generation geotextile fibers. The second generation geotextile fibers are made as fabrics manufactured by choosing specific textile material, processes and finishes suitable for geotechnical purposes using the conventional manufacturing techniques. The manufacturing of inlay composite by just spinning is an example of the second generation geotextiles. Selected synthetic fibers are used along with jute and coir were used for the production of second generation geotextiles. The third generation geotextiles are specifically designed and developed with a new and a purpose for geotechnical application following technically new process and finish. Herein the application is defined first, then the properties required are listed, and then the fabric is designed to suit the application with the particular properties. Examples are geogrids. Coming to the definition of geotextiles, they are defined as any permeable textile material used for filtration, drainage, separation, reinforcement and stabilization purposes as an integral part of civil engineering structures of earth, rock or other constructional material. This is defined by textile terms and definitions. Another definition is woven, non-woven or knitted fabrics, generally known as geotextiles, made from synthetic fabrics of polyamides, polypropylene, polyester or polyethylene. These are used in civil engineering works as drainage blankets and as a means of improving the stability and load-bearing quality of soft soil. This definition is given by the Dictionary of Geotechnics. Now we shall see the classification of geotextiles. Geotextiles are mainly classified into 2 groups based upon its property as porous and non-porous textile material. In simple terms, these are fabrics which will allow air and liquid to pass through and ones which will not allow. Example for porous geotextiles are Geogrids, Geo Nets, and for non-porous geotextiles are Geo Composites. Now we shall see the materials used for manufacturing of geotextiles. The common materials used for manufacturing of geotextiles is grouped as natural and synthetic fibers. The common natural fibers used are jute, hemp, coir, cotton and PET polypropylene, polyethylene and glass fibers are synthetic fibers respectively. Generally, natural fibers are used for making porous geotextiles and synthetic are used for non-porous geofabrics. Now we shall see into the construction methods used for geotextiles. Geotextiles are made by oven, knitted and non-oven techniques. Oven geotextiles is made by natural and polypropylene fibers with specific ends and picks. They have good tensile strength, grab strength, punch resistance, elongation, thermal and stability and UV resistance. They are not affected by mildew, fungi and chemicals. The oven fabrics cater functions of separation, stabilization, filtration, erosion control and marine protection. The application of non-oven geotextiles range from road construction, retaining walls and embankment, airport runways, slope reinforcement, landslide control, breach reclamation and marine construction. The netted geotextiles is featured with high strength, even deformation in length and breadth, high water penetration and softness. These are used in drainage of dams and water reinforcement of dams, filtrations in industrial and soil blocks. The non-oven geotextiles are classified as based upon the type of bonding, namely mechanical, chemical and thermal. In case of mechanical bonding, spun-laced fabrics, needle-punched and stitched bond fabrics are manufactured, whereas chemical bonded fabrics are made by application of chemicals and thermal bonding fabrics are made by the application of heat. These fabrics are made with a width of 2 to 6.5 meters and GSM of 100 to 1000. Generally, these are many layered fabrics. UV protection and resistance against aging is given to Geo non-oven fabrics. These fabrics are used for separation, filtration, drainage, reinforcement, protection and liquid barriers. Now we shall see the functions of geotextiles. The major functions of geotextiles are confinement, filtration, reinforcement, drainage and protection. Confinement. The major property of geotextiles, namely porosity, toughness and strength enhancement of the fabric to divide two types of soil or material from mixing with each other. Filtration. Filtration is the process of separating two states of matter. It is considered as a very important application in the industry and civil work. Geotextiles is used for filtering, ditch lining, beneath roads, water disposable areas and drainage basements. Next one is reinforcement. In many cases, the strength of the soil, earth or a particular area which is weak needs to be strengthened. Geotextiles made with soil and jute bonding provides this property, hence it is used as a soil fabricator, improving the quality of the soil. Next one is drainage. Water is carried across vertically and horizontally along the earth from one place to another. Geotextile facilitates this movement of water without damaging the surrounding areas with its application of permeability. The next one is protection. Landslides, entry of river water during floods and storms cause huge damage to crops and wash away the soil. This can be prevented through the application of geotextiles. Now we shall see the properties required for geotextiles. There are three main properties required for geotextiles. These are its mechanical responses, filtration ability and chemical resistance. First one is mechanical response, which is the ability of the textiles to perform work in a stressed environment and resist damage in any tough environment. Filtration is the ability or capacity to transfer liquid from solid liquid mixture and limiting the passage of solid that are hanging around in a liquid media. Chemical resistance is the ability to withstand against erosion caused by chemicals and effluent which pass through the geotextile fabrics. we shall see the application areas of geotextiles. The first one is civil engineering. Geotextiles is used in road and pavement laying, strengthening of slopes, protection of tunnels, railway tracks, and drainage, and plantation bed stabilization. In marine engineering, geotextiles is used in soil erosion control and embankment protection and waterway protection. In case of environmental engineering, geotextiles is used in landfills and water waste management. Now we shall see the different types of geotextiles. The major types of geotextiles are Geogrids, Geo Nets, Geo Membranes, Geo Synthetics, and Geo Composites. The first one is Geogrids. Geogrids represent a rapid growing segment within the geotextile areas. Geogrids are plastic filaments, roving, and tapes, etc. formed into an open grid having large opening, unlike oven, non-oven, and knitted textiles. This hole-like structure may vary in size from 1 to even 10 cm. They can be monoaxial or biaxial, which means they are stretched in one or two directions for improved physical properties. Both the types of fibers are made of high density polyethylene and is used for as reinforcement. The major function of geogrids are stabilizing soil mass, creating a composite soil mass of increased strength, reinforcement steel to contract, and the ability to carry higher load by soil structures. The application of geogrids can be listed as retaining walls, steepening slopes, repairing slope failures, landslides, embanking fills, earth dams or soft soils, stabilizing landfills, pavement for reinforcement, and as an insert between geotextiles and geomembranes. The next one is Geo Nets. Geo Nets are usually formed by continuous exertion of parallel set of polymetric ribs at acute angles to one another. When the ribs are opened, relatively large gaps are formed into net-like arrangement. Geo nets are made of polypropylene and polyethylene. Geo nets are used exclusively for drainage capacities for applications like water drainage, behind retained walls, slopes for rocks, beneath sports field, building foundation, drainage of landfill slide slopes, above landfill liners, and surface water drainage. The next one is geomembranes. Geomembranes are impermeable membranes used where the primary function is to have a solid barrier for liquid. Geomembranes are made from continuous polymetric sheets that are very flexible, but at the same time they should be solid without deforming when exposed to stressful environment. Geomembranes are used in applications such as liners for water canals, water canals, solid waste landfills, covers for solid waste landfills, waterproofing within tunnels to control odor in landfills, infiltration of water in sensitive areas, and beneath overlay of waterproofing layers. The next one is geosynthesis. In the field of civil engineering, membranes used in contact with or without soil are known genetically as geosynthesis. This term comprises of permeable textile, plastic grids, continuous fibers, stable fibers, and impermeable membranes. The next one is Geo Composite. Geo Composites are polymetric products made from connecting two or more type of geosynthesis. The best feature of different materials are combined in such a way that the benefit cost ratio is maximum at effective cost. The major properties of geocomposites are high tensile strength in the warp and weft direction, low elongation, ability to withstand excellent temperature range, good anti-age and anti-alkaline resistance, reduce cost in the construction, extend service life of road, and prevent deflection cracks. Application of geocomposites are separation, reinforcement function, and pavement. Coming to the conclusion of geotextiles, geotextiles is an upcoming field with many number of applications. Due to its varied properties, new applications are seen and can be improved through researches. Countries across the globe are concentrating on the production of geotextiles, especially for roadways and control of natural calamities. In a nutshell, geotextiles can help India to find income generation activities and research.